Hello everyone, this is KP the Math G, and we are talking about separation of variables. And yes, we're looking at part one because my idea or my thought is to have three parts to this. Two parts where we start off with a couple of easy ones, and then the third part where we find a particular solution, okay, like we did before on a previous video. Let's start with this. What does it mean to separate variables? Well, we want y with y on one side, and we want x with x on another side. All right, and so let's see how we do that. First of all, this is called a differential equation. If you see dy over dx equals something, that's a differential equation. So we have to get rid of this dx. We want just dy on this side. So let's do that. Let's multiply both sides by dx. How are we going to do that? We'll multiply both sides by dx. Notice that on this side that the dx's divide out. And we're left with dy is equal to 2/3 y dx. Now, we have a problem yet still because we have the y with a dx. The 2/3 is okay. Alright? But we have this y sitting here. So how do we get rid of the y? Well, we can either multiply by 1 over y, or we can simply divide both sides by y. So let's do that. Let's divide both sides. Either way, it does not matter. If we divide by y on both sides, this side should be familiar to you. Dy over y is now 2/3, 2 over 3 dx. Okay. Now, with the separation of variables, we still have to take the antiderivative, and we're going to come up with a general solution, okay? So, to do that, we have to do this. This side and this side needs to be integrated. Well, I know what, don't you know what the antiderivative of dy over y is, right? Well, it is, let's put it up here, okay, it is ln of y. Now, absolute value bars, here again, that's probably up to your teacher or instructor or professor. ln like this. This one here is easy enough. The antiderivative of dx is just x. So we're going to put the 2/3 x right here. Now, both of these have a plus c. We can make this one plus c1, this one plus c2, but since c is general anyway, I like to put the c on the side of x. And that just makes it simple. Okay? Alright. In other words, what we could have done was, okay, well, we got ln of y plus c1 is equal to 2/3 x plus c2, and then subtracted c1 on both sides, and then we would have had ln of y is equal to 2/3 x plus c2 minus c1. But here again, if I let c2 minus c1 equal to c, then I have ln of y is equal to 2/3 x plus c. And instead of doing all of that, I just soon just let this b equal to c like that. Now, if you want to do that, that's fine. Some professors will say, do this, and then let this, but for the most part, if you start off just saying that from the beginning, maybe, you can just go ahead and just say, well, this is just equal to c. Alright, that's equal to 2/3 x. So ln of y equals 2/3 x plus c. Alright, so we could go ahead and solve for, some people solve for c, some people solve for y. In this particular case, I'm going to solve for y. And we're just, to get this y, I wonder how we can get rid of this ln. Yeah, that's right. We can introduce the e. ln y is equal to e. You have to put it on both sides. If you have e on one side, you have to have e on the other side. Oh, by the way, okay, there we go. Now e to the 2/3 x plus c. And I'm going to get into this discussion right here in a little bit. What is this? Yeah, it's just the absolute value y. Okay, ln e is going to get rid of that, isn't it? Then we can say this is e to the 2/3 x. Okay. Let me emphasize something here, and we're going to write it in a certain form. Okay. E to the a plus b, well, we could say c, alright, is equal to e to the a times e to the b. Alright, so we can do that right here. Alright, this is times e to the c. Alright, and so since e is never, we don't have to worry about this being negative now if this is all in terms of e, so I can remove the absolute value bars. Okay, and now let's do one more let e to the c just equal, we can make it c1, just equal c. Alright, if you want to make that c1 throughout, you can, but e to the c1 is just c. So this is just c, so we can say y is equal to e to the 2/3 x c times c, or we usually put c in front, c e to the 2/3 x. A lot of this is written in the form of a growth or a decay type problem, but in this, well, so anyway, e to the 2/3 x right here. Okay, that is probably going to be okay there. And when we're trying to find a general solution, then, well, we'll know what c is. Alright, so it's going to be a particular number. Alright, so really all we did is we just had to get rid of that dx, and then after we got dx on this side here, we got rid of our y over here and moved it over here, didn't we? Okay, so then we integrated both sides, and then we just kind of cleaned up a little bit. ln y is ln y, which is just y, and so you get all this. Okay, alright. One more problem. Let's just go ahead and turn the board over. We'll do one more quick example. Alright, I want to kind of hone in on the ln. We got one with ln. Let's do another one where we have, in this case, ln on both sides of the equation. So we're going to really have a pretty simple problem here for example 2. So for example 2, we're going to have another problem. dy over dx is equal to y over x. All right. Now, how did we do this last time? Well, the first thing we did was we got rid of the dx over here. This is easy because this is already isolated like this. So let me get a different color because sometimes we don't like to have this, you know, I like to kind of change up just every now and then. Let's rewrite it down here. dy over dx is equal to y over x. Now we'll multiply both sides by dx. Alright, that's going to change a little bit because we're just going to be left with dy on this side. And granted, these problems can get a little more difficult, but this one right now we're starting off light and easy. Now we still have y over x dx. The x and the dx are great, but this y here needs to be here. Now, it doesn't, well, the y here does not really need to be here. I said it needs to be here. It's here, but it doesn't need to be here. That's what I meant to say. I get words scrambled up sometimes. But, you know, it's okay. It's all good. Now, let's see. Since this y is in the numerator, I can get rid of that by multiplying by 1 over y, can't I? That'll get rid of the y's, but I got to do that on this side. When I do on one side, I do on the other. Now, look at this. This is 1 over y dy. Look at this. These y's are going to cancel out. And actually, this is 1 over y dy is equal to, this is really a 1 here. You can't just erase it. You got to have something in this numerator. So 1 over x dx. And again, if you notice this is ln. Now, some people like to multiply the 1 times the dy, and they'll get dy over y is equal to dx over x. And that's fine too, but now we can integrate this. Okay. We have from here ln y is equal to ln x plus c. Do not forget the plus c. I'm reminded that when I used to do the workshops or go to workshops, and we talked about this, those who were trying to teach me how to do this, you know, we were all emphasized, all the teachers were emphasized, do not forget that plus c. Tell your students to put that plus c in there, and that's what I'm telling you also. Don't forget that. Alright, so here we go. How do you get rid of ln? How do you get this y by itself? Well, e ln y is equal to e ln x plus c. Raise everything up. Don't leave the c out here. Don't just say plus c out here like this. Don't erase this and say, oh, that's plus c there. Don't do that. This whole side needs to be raised up. If this whole side here, which is just y, ln y needs to be raised up, well, this ln x plus c needs to be raised up too. So don't forget that. Don't just put plus c here. You have to raise all of it. Okay? Now we have, this is just y. Now remember, we could say the absolute value of y. And we could say this is the absolute value of x. Well, wait a minute. We have to do something a little different here. Think about what we just said. This is, remember from the last example we said e to the a plus b is e to the a times e to the b. Alright, so we can say e to the ln x times e to the c sub 1. The reason I want to make that c sub 1 like that. Alright, so now e ln x is just x. Alright, e to the c. Now remember we said let c1, let e to the c1 equal just c. This is a constant, this is just a number anyway. And keep that in mind, that's just a number. So let's put it in front. So we have the absolute value of y is equal to c e, no, I'm sorry, yeah, c times the absolute value of x. And okay, so provided that we can remove those absolute value bars, I think sometimes they do, and so instead of just saying the absolute value of y, we're going to assume that that's positive. In x2, just say cx. And remember, c is a constant. Okay, x is a variable. It's like y is equal to something x. 1x, 2x, 3x, 4x, and so on. Negative 0.25x, whatever, but this is y is equal to cx. And that's the way I think, you know, that when I say I think, this is the way we should handle this right here. This part right here becomes this right here, okay? And then this is just c. Alright, all of this is just c. So I put the c out in front. Alright? Okay. So that's pretty much all there is to it on this one. Okay. That's a couple of problems that we've just done. You know, this one here had the ln on both sides here. The other problem had just ln on one side. Okay. Alright, so that's what we're going to do. In the next video, if you can join with me in the next video, I'm going to do something where you still have to do, we're still doing the general, you know, the general C right here like this, but you know, we're not finding a particular solution as of yet, but we are going to have to do that. You know, remember that substitution that we did? I had 5 lessons on that from those last 5 videos. We're going to have to incorporate substitution in with this separation of variables, and I want to do a combination of that, but we want to reserve that for one problem because that's going to take a while to look at everything there, all the little nuances that go with that. Well, anyway, this is KP the Math G. Don't forget now to subscribe. I have a few subscribers. I need a few more, but I mean, that's if you want to subscribe, please do that. And if you want to make a comment, please make a comment. You can comment, hey, appreciate you, KP the Math G, or you can say, hey, you could have done this a little bit, you know, done it this way. And you know, I'm open for those suggestions here, even these absolute value bars. You know, I'm open to those suggestions. So please make those suggestions as you need to. You know, please help me so I can help you do this better. Because I want to be at my best. Because after all, I am KP the Math G, signing off. Hopefully you have a great day. And the New Year's coming. So Christmas time is over, but I'll still say it again. Merry Christmas, that's a belated Christmas, and now happy upcoming New Year. Alright, KP the Math G signing off. Have a great day.